So I now have my X-axis DRO in, except for the cover that's going to go up on the top here, but it's functional at this point. I had to take this cover off. Well, part of it is because I had to get the bolts in on the back side of this. There's a pair of nuts on the back side. But while I was in there, I wanted to clean and inspect back there. The oil return is back here for the cutting oil. So I cleaned that all up. I painted this back plate on both sides just for corrosion resistance, and re-siliconed around and reassembled everything. So this is all functional now. You can see the green. So I've got good read height on here, and I've already tried this out and it measures good. Okay, so I've got everything lined up for the next cut. I probably should be changing to a wider cutter because I want to go off the edge all the way out here. And this is just leaving a little sliver at the end, but rather than take all the bracket off and change the cutter and all that, I'm going to do one pass with this, and then I'll go back and I'll just do a real quick pass with a high feed rate to get that sliver off. I shouldn't have to go this slow. I should be able to speed it up quite a bit because it's just a thin little bit. It's not going to really be working that hard at all. Now this is a much deeper cut. I'm cutting 9mm. Just move that up a little. And we're actually starting to fill up the channel here with the chips. So looking from the back here, you can see that is just the tiniest little sliver that's left. So I think all I have to do is I'll run it back to the beginning, and I'm just going to walk it over just a tiny bit, and that should come right off of there, no problem. I don't know how much you can see here through the camera, but the bottom of these cuts looks really good. I'm really happy with the way it's coming out. And here I'm about to make a significant screw up. And I turned up the cutting oil fluid a little bit, the pressure on it, to see if I can get a little better evacuation of the chips here, get them flowing away a little more. running out of room here. Well, I just had a little bozo moment here. Got caught up filming with the phone and missed coming up on this tie down and ended up hitting the shaft here. Didn't do anything real bad yet, but it just scored up the surface there a little bit. But still, I should have been paying better attention. Now, time for this one to come out and get repositioned. Okay, so that's about 4 millimeters shy of where I stopped last. And I'm going to shuffle this down and put it on the other side. Okay, ready for the next section. Okay, so I've got everything repositioned here and I'm ready to continue the last bit. So that was a pretty close call when I came up against the shaft with the tie down. I didn't show it on camera, but I put a dial indicator on there and it had just started to put a little bend in there. So what I ended up doing is I found the high spot on it, and with the shaft stop, I put a 1, 2, 3 block between the shaft and the tie down. I moved the table out and then just brought it up against it in a direction that would push that bend back out. And with the dial indicator still on it, I got it zeroed out, removed it, tested it again, and I got it down to where it's straight again now. But that was a pretty big mess up. That actually did bend it a tiny little bit. But it looks like it's in good. It showed good on the dial indicator, and listening to the blade, it sounds good. So I think everything's all right now. If they really out, you can hear it in the blade because it'll pulse. Because what'll happen, it'll only cut on the teeth on one side. Okay, so now I gotta cut that little sliver off. And I'm thinking, I made sure I fine cutting this. Instead of reversing it, moving all the blocks again. So I've got the table is shut, the feed is shut off right now. And what I'm going to do, I'm just going to move the table inward a little bit. And we'll see, I'll try a little bit by hand just to see if it's going to work all right. Yeah, that looks like it'll work, so I'm going to put the power feed on.
So I'd like to welcome all my new viewers coming from A-Bomb's channel, and I hope that I get to earn your subscription. I'm relatively new to this field, and I certainly don't have Adam's experience by a long shot, but I like to experiment and think outside of the box. And with that, I hope that I get to inspire some of you with your own creativity.
I just picked the speed up a little bit. I forgot to do it before. This is a higher speed right now. The handle is fine a little bit. We'll stop now. Put the wheel in. Trying to reposition.
Unfortunately, I lost that close-up shot I was trying to get. The audio on the other camera was pretty poor. Basically, I sped up the feed rate to what I was supposed to do. I had forgotten it before.
almost at the end now. I'll have to switch those clamps once I get up to the end here and finish off the tail. Then I'm ready to take the support bracket off here and get everything moved around, do the other side. So that'll be up here, up to the other end. And here we go for the last bit. Okay, so I just want to show it with the oil cleaned off a little bit, how this came out. Get it to focus good enough. So I don't know if I'm going to finish this now or in another session for the other end, but it's going to be exactly the same as what I did here, so I don't need to show that. It's just going to get too lengthy. I think you know where we're going here. You can see what the results are. Yeah, I'm real happy with this for the first time doing anything with the horizontal. The results are there. This is what I was looking for. So the next stop I have to do here, if you notice here, the groove doesn't go all the way into the cap here, and same on the other end down here. So that means that this ridge is going to have to get cut short to accommodate this. So I'm going to have the rail go up to basically the end of the table here. Probably right to the end of the chamfer that's here. So on this side, I'll just cut it back a little bit here, which is about 1 inch. I'll measure that out. And on the other side, I'll probably just go past the end of that and go, or to the end of the groove here, stop just a little short and then mill off the rest of this. Just the ridge part that I made here. The other thing I noticed, and I had spotted this before and forgotten about it, is the groove does not go in as deep as this step here. So I will have to lower the height of this ridge just a little bit. So when I mill the ends all the way down to the surface down here, what I'll also do is just come across the top of this and bring it down the appropriate amount. I don't want to take too much, just enough that I can get it to seat all the way up. So the flat surface here will come up against the edge of the table. And that'll still leave enough to lock it in here, but I've got a nice flush surface with the table and everything will fit good. So taking that ridge down, going down 2 millimeters here. Feed rate 3 3¾ inch per minute. I've got the highest RPM here. It's 1500 for the overarm. I really could use more on it, but yeah, this will do. Keeps the spray down with the oil anyways. Don't dare go faster because of the low RPM. With this small bit, I really should be turning faster than this to cut with a faster feed rate. So here I'm finishing up the 2 millimeter cut down on the long strip. This is the other end because I don't have enough travel to do it all in one shot. And as soon as I finish this, I'm going to drop down to do the 6 millimeter cut. Come back to that line that we're going over right about now. Okay, so now I'm coming back. We're just going to go up to that black line there, the first one. So I'll cut into it a little bit there. Okay, so that should be about center of it. So here I'm taking down the notch at the end. I've got 2 more operations I decided to do on this back cover piece, the rail that holds and protects the X-axis scale here. When I fit this on here, and I've already had it on, it fits on good, except for one thing I didn't like. The top of this, I meant to be flush with the top here. It stuck just a tiny bit higher. And when I was originally thinking about this, I kind of figured I was going to clean this up and bevel the back. And then I kind of skipped it. But I'm coming back to that now because it is a little bit higher than the table. It has to be at least flush with it so you can have things extend over the table. And I'd rather have it lower. Where this is already beveled or chamfered on the edge of the table, I'm going to try and get it down so it's basically at the bottom of the chamfer. Come out just a little bit, maybe another 2-3 millimeter, and then I'm going to chamfer the edge of this as well, or maybe more of a bevel. It'll be a little bigger than this, and that'll prevent things from hitting this and dinging it up and banging it around on the screws. It's mainly to protect the scale, but it also keeps it tight against the bottom of the table. So I'm going to do that, and that'll should give it plenty of protection where it's down below the lip and then bevel below that. So now I'm setting up to deck this off. Started trying to cut here, but with all that stick out, it started vibrating too much going this way. So I've done this little setup here, which kind of looks like a bunch of Jenga blocks at this point. Cutter is set up, it's pushing towards the back of the machine. So I've got it, the rail is in between these two blocks. I've got a pull rod that goes from the bottom block up to here. They have threaded holes in them. So I've got that pulled tight, so this acts as one solid piece, and then I've got it clamped to the table here, and I've got it just brought up to the back of this, and just a tiny bit of pressure, not enough to really bend it. And that should give it the backing it needs to keep it from vibrating, at least badly. So we'll see how this does. And definitely way better than what I had the last little bit when I first tried this. In fact, I think I'm going to go back and I'm going to try taking my full cut. I'm cutting 3mm deep now. That's the full cut I want to do here. Well, it's doing it. I think I want to put a little more tension on here. I'm going to pull this back just a little closer to me because I am still getting a lot of vibration here. Okay, so this should finish up. I may get some vibration in here. This is a pretty long span, but we're going to try it. I put this clamp on here to try and steady it out. I had to rearrange this just a little bit. So far it looks alright, but I may get into a little something here. I may have to keep my hand on it or something to dampen the vibration. Definitely some oscillation in there, but it's within reason. I think we can do this. We're almost in the middle right now. That's going to be the worst spot.
And we'll get you a little bit of slow-mo view here. Also, I didn't film it, but I drilled the mounting holes and the counter bores, which you should be able to see in the video. That process was done on my DIY mini mill build. I like this view of the smoke coming off the flying chips in this shot.
to do this bevel in one pass. It was a little too much for my little cutter. This only has a 1/4-inch shaft on it. It's really not a metal working bit. It works for it, but this is actually for woodworking. It's really at the countersink, but I've used it plenty of times for metal work. What happened is I started spinning the shaft in the collet because it was just too much torque on it, trying to cut that all in one pass. So, and you can see here where it started to spin and it started to drop down. So what I ended up doing for the rest of this is I did it in several passes to lighten the torque on it. And now what I'm doing, I'm just doing a finished pass going back. This is a climb cut, just to clean it up from this rough cut here. Unfortunately, I've got this. I'm not going to be able to get that out unless I cut it down further, which I don't want to do. So I'm just going to have to live with that, but the rest of this should be reasonably good. So the lighter passes definitely seem to be helping because I'm getting a much better finish back here. This is just the first cut-ups from where you can see the step back there.
So here I'm running the second pass for that middle section. And now I've moved the bar down and starting the first pass for the second half of the bar.
So this is the final pass. Once this completes, I should finish this part, except for a little bit of filing the burrs off, which isn't much. Then I got to clean the oil off of everything, including the table, and we're going to silicone the back of it so that it's got a tight seal against the table, because I don't want the oil going down into the scale once this is all set up. And screw it all together, and that should complete it. Okay, and that should complete it. Okay, so I'm in the middle of installing it now. It's all done. I've got silicone under here, and I'm just working my way back and forth here, squeezing it down nice and tight, and then I'll wipe off the excess silicone that pops out up here. And that will complete that part. This is most of the way there already. We look close here, see there's a little bit of a step down here to the top of the ledge on the piece that I made, and then we've got the chamfer there. So that's basically what I want. So if we've got something laying across here, well, I put my 1, 2, 3 blocks away. That would be ideal to show it, but you should be able to see that. It drops down a little, so if something hangs over, it's not going to hit it. And if it leans, it's got nice rounded edge on there. I'd have to really hit this hard to do any real damage on it. I just wanted to show under here real quick. You should be able to see that drip edge there. You've got the scale towards the back, towards the table, and there's a little gap up there, and then you have the drip edge. end of the table here underneath, and I wanted to put this up under there like that, all the way up, and then up against the back of the bracket. And I was thinking originally to cut a clearance for that upper screw there. Problem is it just clips where the screw for the DRO scale is going to attach. So I can't do that there unless I relocate that screw. I don't think I want to do that because this is probably the best layout for them. So I think what I'm going to do instead of putting it up by the top, I'm going to put it on the lower edge down here, more like that, and up in here. And that puts the DRO mount screw, or the scale mount screw, past the bracket mount screw enough that I can just cut a notch or an opening there and just go over it, and I think I'll be alright like that. So I'm just going to take some marks here and see just where that lines up, and then I'll carve out a little spot for that head to go in there. And then I should be able to get this to seat good. And the rest of that should be enough threads to hold it on. I'm debating, I may actually cut this shorter because the scale is longer than I need. I can cut almost 2 inches off of it and shorten that tail up a little bit. It's still going to stick out, but it'll be a little less in the way if I bring that back 2 inches. So I think I may do that, end up re-drilling that hole and re-tapping it on the end. Doing my mount holes to put this whole bar on the machine. I'm doing this on the mini mill because this one has the DRO set up right now. So I wanted these centered, you know, from one side to the other. So it's just easier to do this with the DRO. Plus, I can change the bit, maintain my alignment on here just by zeroing out. And here we have the scale mounted on. So as I showed earlier on the other one for the x-axis, you've got a little bit of adjustment here where the slot is oval. Right now I've got it flush with the top of the mounting bar, but if I need to, I can adjust that. I just ended up shortening the scale. I took the stainless steel cover off and I cut it on the bandsaw here at a very slow rate. And one thing I did is I pre-scored the magnetic strip with a knife first, just to make sure that I didn't tear this in a bad way. I also cut with the blade going into the strip, going down that way, so it would stay pressed against the aluminum backing. I re-threaded the holes for the cap to go back on. This just slides in, it's just a groove here. And here we have the scale mounted on. So as I showed earlier on the other one, you've got a little bit of adjustment here where the slot is oval. Right now I've got it flush with the top of the mounting bar, but if I need to, I can adjust that. So here I've got a little bit of a mock-up of how I'm going to do the bracket for the reed head. So these are the brackets that come with the scales. I've got that put together, and I'm going to use this angle iron. It'll be inboard a little bit more. We get adjustments here. We can take that up when we do that. And I'll put 2 through bolts in here to lock that tight. And I'm going to cut right on this line here. Don't need to go any further than that. And I think I'm going to do it with the bracket facing back. What I'm going to do here is I'll weld some little tabs on down here so that I can get the bolts in, do a circle down below. Okay, so now I'm going to install my bracket that goes to the y-axis scale down here. So it's going to attach to these two bolts on the knee motor. And it was strong enough, it was steady enough, I could just use these top two bolts. I didn't have to do the leg going down. So this is what I ended up with for the lower half of the bracket. That's the tabs I welded on the back. Did a little milling on here, I didn't show it, but pretty simple. I was just had to narrow it out a little bit to get to fit in here. Paint's real soft. I just got done painting this. So I'm leaving the split washers out. It just helps accommodate for the thickness of the tabs down here. The tab is about equivalent to two of those washers, but there's enough thread there that as long as I take that washer out, I should have plenty in there to do the job. I already had this fit up before I painted, so everything's pretty well set to go on here. Okay, so that should do that. The only other thing I'm going to do here, and I'll probably just do this off camera, it's no big deal, but I'm going to put a little strap on here just to hold that right there. I'm going to drill a hole and put a strap on. This one has to float because it moves back and forth with the table. Hopefully you can see that. Got our y-axis here, and let's see, I'm going to move this all the way back. just set my zero here. So there we are. And all the way back. Okay, and the last little bit I gotta do by hand. And back to zero. And if we switch that to inches, it works out to just about 12 inches. I think it's just a hair over it. Oh, a little under. I think if I remember right, I can get 12 if I do the last bit by hand. So let me come back. Okay, so that's actually a little past the zero there. And let's go all the way in again. So let me see if I can get that all the way up to 12. There we go. So it does go full 12. So that completes the three major axes for the DRO. They're all functional now. The only one I'll have left, and this one's probably going to wait a while, is the one that goes for the quill. And one of the reasons I want to wait on that is because I don't know how thick the casting is here, and I'm going to have to drill and tap it. And I don't want to get chips inside of here when I'm using it. So what I'm going to have to do when I do this project, I want to take this apart anyways because I want to check inside here. And when I do that, I think I'm going to break the entire quill system down, or at least down to some basic components to where I can have this casting empty. Clear all the grease out of it. And that's when I'll do the drilling and mounting on here. And then I can clean everything out, fully reassemble, and not have an issue with getting anything inside the assembly. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.